It all started with the motto, "You must have bold goals." With this vision and the desire to explore new ways of acquiring and processing geospatial data, as well as new possibilities for its use, several Czech partners founded a new nonprofit research organization in 2003. Since then, Wireless Info has become a key player in the research and development of solutions for working with spatial data and creating innovative technological solutions, actively participating in more than 30 international research projects. We specialize in developing new technological solutions that simplify the collection, transmission, and management of data from various sources. From map digitization and data collection using sensor networks to the processing and evaluation of satellite data. Our technologies are designed for use across various sectors, such as agriculture, forestry, environmental protection, and regional development, but also in transportation and cultural heritage. We believe that decentralized data sources and open interfaces are the key to developing applications that are not only practical, but also easily accessible to all users. After years of experience, we know that finding the right path is not always easy. In research and innovation, this holds even more true. But the bold goals and the desire to achieve them remain with us. One of the research projects currently undertaken by Wireless Info is the THEROS project. This Horizon Europe-funded initiative aims to develop and test an integrated set of tools to improve the verification of organic and geographic information for food product labeling and to prevent counterfeiting and noncompliance. THEROS leverages various technological innovations and data sources to ensure greater safety, transparency, and interoperability across the quality-labeled food supply chain. The THEROS project brings together 17 partners from 6 countries: Greece, Cyprus, Slovenia, Serbia, Spain, and the Czech Republic. The project is coordinated by the Institute of Communication and Computer Systems from Greece, with Wireless Info and Pošumaví products representing the Czech Republic. The project spans 36 months, with a planned completion date of December 2025. The THEROS project aims to enhance the detection of adulteration and non-compliance in organic and geographically indicated GI food products, with a focus on efficient monitoring of quality and sustainability parameters through affordable, digital, and scalable solutions. It seeks to strengthen traceability across the quality-labeled food supply chain by leveraging innovative technologies and approaches that ensure secure and transparent data governance throughout the entire value chain. Additionally, the project facilitates effective management and harmonization of data collected at various stages of the supply chain, supporting improved decision-making and ensuring interoperability with existing systems. A core goal is to develop new business models and approaches to prevent adulteration in quality-labeled foods while increasing awareness and quality assurance. The effectiveness of the THEROS integrated toolbox will be validated and demonstrated through 4 planned validation campaigns, paving the way for the rapid adoption of the proposed systemic innovations. The THEROS project includes a range of innovative components designed to ensure authenticity, quality, and transparency in organic and GI-labeled food products. The EO-based ecosystem services utilize satellite data and machine learning to monitor and verify organic farming practices, track crop types, and monitor ecological focus areas, with multi-source data integration and high-resolution satellite imagery enhancing monitoring capabilities. MEMS-based photonic systems feature a handheld VIS-NIR scanner that detects substances prohibited in organic farming, offering a simple field-deployable solution for identifying mislabeling in soil and food products. To maintain quality during transport, the IoT sensor network comprehensively monitors environmental conditions and ensures authenticity, employing temperature, humidity, and position tracking through QR codes and RFID chips. Additionally, the DNA-based Authenticity Kit provides a portable solution for verifying food origin and authenticity using DNA barcoding and metabarcoding. This kit identifies unique DNA signatures of specific products and regions to prevent mislabeling and adulteration. The blockchain-based traceability system enhances transparency and traceability within the supply chain, using Hyperledger Fabric to secure and immutably track data across participants. Paired with this, the dynamic digital product passport offers a mobile application for real-time assessment of organic and GI products, supporting secure transactions and promoting transparency. This application tracks location and time to improve supply chain integrity. Data management and harmonization are achieved through a cloud-based platform that integrates diverse data sources and harmonizes them for seamless interoperability among THEROS components. This enables large-scale monitoring and verification. The verification engine further ensures compliance by validating organic and GI labeling at each stage of the supply chain, using smart contracts to enforce compliance and transparency. The Green Accountability Tool provides an interactive interface for environmental monitoring, offering recommendations for sustainable farming practices and facilitating regulatory reporting and data-driven decision-making. Finally, the digital marketplace offers a platform where regional organic producers can promote and sell their products, supporting short supply chains and minimizing food mileage while ensuring product authenticity and quality throughout delivery. These THEROS tools will be tested in a real-world environment through 4 pilot demonstrations in 4 different countries. In Serbia, the focus is on preventing adulteration in processed quality-labeled foods, such as flour. The project will deploy EO-based monitoring, MEMS photonic systems, and blockchain-enhanced traceability to improve detection of fraudulent practices, optimize organic farming processes, and verify product authenticity across a complex supply chain. In Greece, the pilot will concentrate on preventing adulteration in fresh and bulk organic commodities. THEROS tools will improve organic production verification, traceability, and decision-making. Farmers will use MEMS photonic systems for on-site inspections, supported by blockchain technology to enhance transparency and carbon footprint assessments in the supply chain. In Spain, the focus is on preventing adulteration in geographically indicated GI products, specifically the Galician mussel. This pilot will implement blockchain and DNA-based authenticity tools to track and verify product origin and authenticity through each supply chain stage, strengthening consumer trust and transparency for GI-labeled foods. In the Czech Republic, the focus is on developing a data-driven business model to combat food fraud in organic products. The pilot will introduce a digital marketplace and an IoT-based monitoring system for transportation conditions, ensuring traceability from farm to consumer while promoting the availability and awareness of organic foods. As part of the THEROS project, Wireless Info is primarily involved in tasks related to the business-driven digital marketplace and IoT sensor network. The THEROS digital marketplace for organic foods and protected brands is mainly focused on supporting short local supply chains. The goal is to promote local producers and retailers of local products and to facilitate direct contact between them and customers. The marketplace enables the direct offering of various local producers and retailers. Individual producers and suppliers can register directly on the marketplace, providing customers with access to a broader portfolio of organic foods and protected products. Customers place orders on the digital marketplace, and individual merchants receive these orders. The products are then either sent by suppliers to the marketplace's warehouse or directly to the customer. Within the THEROS project, every order and subsequent delivery is recorded using blockchain technology, which prevents data tampering. The marketplace also includes the option to monitor transport conditions to ensure the quality of the goods and prevent unauthorized tampering during transit. If the customer chooses monitored transport, the goods are placed in special boxes equipped with sensors that monitor temperature and humidity, as well as a magnetic sensor that detects if the box is open. To track the transport process, we have developed a special web application that visualizes sensor data on a map, allowing users to check the entire delivery process. The customer, merchant, and transport service can receive a report on the transport process, highlighting any extreme values. Both of these technologies are being tested as part of the pilot solution in the Klatovsko region of the Czech Republic. We believe they will help achieve the goals of the THEROS project, particularly by supporting the trade of organic foods and protected products, ensuring their quality throughout the logistics process, and contributing to greater transparency and trustworthiness of the entire process. Another ongoing project is Data4Food2030. This is a 4-year project funded by Horizon Europe, involving 24 partners from 12 different countries. Data for Food 2030 aims to improve the data economy for food systems by expanding its definition, mapping its development, performance, and impact to create new insights and opportunities. The project is coordinated by Wageningen University and Research, and in the Czech Republic, it is represented by Wireless Info and the organization UDLAVA, who are implementing the Czech case study in the Klatovy region. The main theme of Data for Food 2030 is what we call the data economy. We need to address the lack of understanding of multiple aspects of the data economy for food systems, in which data are not only a new economic asset, but a strategic good in the transition to sustainable food systems and to a fair and inclusive society. We need to deepen our understanding and shared perspective of its development, performance, and impact, using an interdisciplinary systems approach to avoid possible pitfalls and to ensure that it leads to a desirable future state. We are working towards several objectives. The first is to create a unified definition of the data economy for food systems, which will be universally understandable and useful for a wide range of experts and institutions. This definition is followed by the creation of a monitoring system that allows us to better track how data flows within this sector and how effectively it is utilized. This system should help identify gaps in data flows and suggest ways to improve data sharing and access. To better understand data utilization opportunities, case studies are being conducted. In 9 European countries, including the Czech Republic, the project explores specific examples of data flows within the food supply chain, from farm to processing, sales, and the end consumer. In the Czech pilot project, we focus on connecting data between agriculture, tourism, and regional development in the Klatovy region. We believe this data can help not only improve agricultural production efficiency, but also support local tourism and regional economic development. The pilot study, Intersectoral Data as a Service, conducted in Klatovy, focuses on analyzing data flows generated within short food supply chains. We are examining not only the vertical flow of data from producer to consumer, but also horizontal flows, the scope of individual data groups, and the possibilities of their utilization and cross-sectoral linking. A significant part of this study is exploring how intersectoral data could support local tourism. Through the Czech pilot project in Klatovy, we hope to help create a model for better data sharing among farmers, processors, and consumers. This includes developing an interactive map or application featuring local producers, markets, and events. Tourists would thus have better access to information on regional specialties, and events and local producers would have a chance to present their products to a wider audience. In the long term, this project can support the regional economy, increase awareness of the quality of local foods, and connect different sectors, which could serve as inspiration for other regions. The Data for Food 2030 project offers a new perspective on data utilization within food systems, benefiting not only the food sector, but also local economies and tourism. Based on experiences from Klatovy, we hope to expand the insights and models we develop here to other regions and connect them with additional sectors, such as tourism and education. We believe that the results of Data for Food 2030 will be beneficial not only to our partners, but also to regions across Europe.